Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing. Down there, life continues.
Good day, great listeners. Let's hope you had a lovely week. Our lesson today in natural sciences, we're going to be looking at energy and change, and then our topic is visible light. All right, it is visible light. Then we're going to be looking at the subtopic absorption and reflection of light. Let's check our lesson objectives. Remember, by the end of the lesson, we need to achieve something. We need to achieve something. We are going to be looking at the lesson objectives immediately after this ad break. Good day, great eight learners. Welcome to the Natural Sciences lesson. My name is Torigle Tebe, and this program is proudly brought to you by the Houghton Department of Education. Remember, this term we are looking at energy and change, and our topic is visible light. But today we're going to be looking at the subtopic absorption and reflection of light. Let's check our lesson objectives, grade 8. Remember, we need to achieve something by the end of the lesson. What is it that we are going to achieve, grade 8? We are going to describe the absorption of colors. We are also going to explain why an object has a certain color. And we're going to state how light is reflected. And we get this all from the CAPS document, page 50 to 51. And then pre-knowledge. We're looking at the prior knowledge that we already have. Remember, when you're in grade 7, we did the transfer of energy when we focused on solar energy. And now in grade 8, what have we done? Grade 8, we've also done the radiation of light and spectrum of visible light. This is the foundation of our lesson. We already know what we're going to be talking about because this was the foundation of this lesson. Okay. And then we've got a baseline activity. The baseline activity is there for us to remember what we did in the past. Let's check question number 1. It says, explain why a car looks blue. Then 2, state why everything appears to be black when you close your eyes. And then 3, why is glass transparent to visible light? 4, what will you observe if 7 colors? What would you observe if 7 torches is shining a light of only one of the 7 colors of the rainbow? Shine their light together on the same spots. I'll give you 5 minutes to answer those questions. Done writing grade 8. Good. Let's check our answers if we wrote correct answers. But remember, if you want to ask a question or you want to send us a picture of your answers, send to 079 578 2908. The WhatsApp number again, 079 578 2908. All right, let's check the first question. It says, explain why a car looks blue. Why should a car look blue? It is when an object has a specific color. For example, here the car is looking blue. It is because it reflects only the color blue and absorbs all the other colors of the visible spectrum. Right. Here, if you look at the color of the car, if the surface is blue, let's say this is the surface, it is blue. And then the color, white color, that is the visible light, it will strike the blue surface. And then what's going to be reflected? It is the blue color. What is going to happen to the other colors of the visible spectrum? They will be absorbed, right? But the color blue will be reflected to our eyes. When our eyes receive the light, then we can see the color. Do you get it? But if there is no light that is getting to our eyes, we cannot see any color. Then that will be black. It will be dark. All right. And then let's check question number 2. It says, state why everything appears to be black when you close your eyes. It is because no light will be entering our eyes. All right. We only see color when light is reflected to our eyes. That's when we can see color. But when the colors of the rainbow or the visible spectrum strikes a surface and no color is reflected or no light is reflected to our eyes, then it will be dark, it will be black, because all the colors of the visible spectrum will be absorbed. Do you get it? Good, grade 8. And then let's go to number 3. Why is the glass transparent to visible light? It is transparent. Why? Why is the glass transparent? Because light can go through. All right. Light can pass through. For example, this hand is opaque. You cannot see through it. If light strikes on an opaque object, what's going to happen? The light is going to be blocked by an opaque object, then it will cause a shadow. But here, if the glass is transparent, the light can travel through. Do you get it? Then you can see through the other side. That's why we are in class here. If you look outside, you can see trees. You can see people going past our classroom. Why? It is because light can travel through transparent glass. Okay, it can travel through transparent objects. Do you understand that? Good. Then let's check question number 4. What will you observe if 7 torches, each shining a light of only one of the 7 colors of the rainbow, shine their light together on the same spot? Right? That will be white light. Okay, it will be white light. And then let's check our terminology. Grade 8 terminology is very important because you will be given terms to define from now up to grade 12. These are given marks. Each term carries 2 marks, so make use of these terms. Make sure you understand them. All right, we've got reflected ray. This is the light ray that is reflected off the surface of an object. What do we mean if we say it is reflected off the surface of an object? For example, this is the surface, all right? Let's say this surface is what? Is yellow, all right? And then the colors of the visible spectrum, these are the rainbow colors, all right? They strike the yellow surface, and then the yellow light is going to be reflected to our eyes. If the yellow light is reflected to our eyes, what are we going to see? Our mind is going to interpret it as color yellow. Do you get it? And then what will happen to the other colors of the rainbow or the other colors of the visible spectrum? They will be absorbed. Do you get it? That's why we're not going to see them. We're only going to see the color that is being reflected. All right? Therefore, reflected ray, this is the light ray that is reflected off the surface of an object. For example, this ray that is coming in, it is incoming ray. This is the incident ray, this one. This is the incident ray. And then this one that is being reflected from the surface, this is the reflected ray. Reflected ray. This is the one that will tell us, that will show us the color of the reflected ray, the color of the surface. Okay. And then we've got another word here, perpendicular. All right. What do you mean when we say perpendicular? For example, at a right angle relative to another line or surface. All right. That is perpendicular. A line that is perpendicular to another. There will be an angle. For example, a right angle. Okay. If this line is perpendicular to this one, then it's going to form a right angle. Okay. And then incident ray, the light ray that strikes the surface of an object. When we are talking about the incident ray, we are talking about the incoming ray. All right, let's do this. This is our surface. Let's say our surface is blue. Okay. And then the colors of the visible spectrum will come like this. The incoming ray, it is called the incident ray. The incident ray. And then there will be a normal here. Okay. And then the outgoing ray is the reflected ray. Reflected ray. Okay. Therefore, the incident ray is the incoming ray. All right. And what about a normal? This is a line drawn at right angles to the surface of an object. It is an imaginary line. For example, this is the normal here. Normal. Then incident ray, then reflected ray. All right. Then the angle from the incident ray to the normal and from the normal to the reflected ray, it should be 90 degrees. It should be at 90 degrees. Okay. And then let's move on with our terminology. Angle of incidence, an angle between the normal and the incident ray. Do you understand that? All right. Let's say this is the surface, and then this is the normal. Remember, the normal, we say it is an imaginary line. All right. And then this is the incident ray. Okay. If we say the incident ray, this is an incoming ray. All right. And then we're talking about angles here. This is the angle that we're talking about, from the incident ray to the normal. Okay. This is the angle we are talking about. And then the angle of reflection, we are talking about the angle between the normal and the reflected ray. Remember, we said this is an incident ray, and then the normal, which is the imaginary line, and then we've got the reflected line, this one. Okay. Then angle of reflection, this is the angle between the normal. Remember, this is the normal. This is the normal. Then this angle, it is angle of reflection. Do you get it? And then scattered light. Light that reflects in different direction because it is scattered with no regular pattern apparent in the reflection. This is scattered light. Okay. And then let's look at absorption of light. When we are looking at absorption of light, not all surfaces reflect light. Remember that. Light can be absorbed by some materials. Some materials absorb light waves or certain wavelengths from the visible spectrum. And the light is absorbed different by different materials. For example, a mirror, it will absorb no light, it won't absorb light, while a green leaf will absorb all the colors except green. Because it is green, then green will be reflected to our eyes. Then we'll see the leaf as green, okay, because of the reflected green lights, okay, that comes into our eyes. Remember, the color that we see is the one that is being reflected to our eyes. That's why we see that color, okay. And then a material has color because it absorbs some of the colors in the spectrum and reflect other colors. For example, the green leaf would absorb all the colors of the visible spectrum and only reflect the what? The green into our eyes. Then we'll see the leaf as color green. Are we together? Let's look at the mirror. This is the mirror here. You will see all those plants that are being reflected here and all the furniture that is there. You can see it because it has got a what? A smooth surface. All right, let's move on. If some of the colors in the visible spectrum are absorbed and the rest are reflected, then the object will appear to be the color of the reflected light. Okay, what do you mean there? When the other colors of the reflected light rays. Okay. Let's say you've got different surfaces. For example, here we are given a yellow surface. Okay, this is a yellow surface here. And then the colors of the visible spectrum are incident rays. They are coming in. And then all the other colors are being absorbed. But only color yellow is being reflected. Then our eyes see color yellow because the yellow color is being reflected to our eyes. Our eyes can see light and it interprets it as yellow. Are we together? But if the surface is black, what do you think is going to happen? All the colors of the visible spectrum will go and they will be absorbed by the surface black, and no color will come to our eyes. Therefore, we will see it as black because no color is coming to our eyes. No color is being reflected. Put together. And then, let's say the surface is blue. The colors of the visible spectrum will strike the blue surface, and then color blue is going to be reflected to our eyes. And then what are we going to see? We are going to see blue because the color blue is the one that is being reflected to our eyes. Are we together? Good. An object such as a piece of white paper looks white because almost all the light is in the visible spectrum and is reflected back, and very little is absorbed. A black object looks black because all the frequencies of light are absorbed and not reflected, and therefore no light reaches the eye. If no light reaches the eye, what are we going to see? Black. It will be dark. For example, if we all close our eyes now, what do you see if you close your eyes? Grade 8. It will be black. Why? Because no color is entering our eyes. If we can't see any color, any light entering our eyes, then there's no color that we're going to see. That's why when you close your eyes, you only see dark, you only see black. Okay? because no color is entering your eyes. But if a color is entering your eye, if light is entering your eyes, then it will be interpreted by the mind. For example, if the surface is yellow, then you will see yellow. If the surface is red, then you'll see red. If the surface is blue, then you'll see blue, because blue light will enter your eyes. Are we together? Good. Let's move on. All right, let's check this beautiful picture. White light is coming in. These are the colors of the rainbow. This is the visible spectrum. All right. What about the surface? The surface will determine whether you're going to see light or no light. All right. The surface is black, therefore all the colors of the visible spectrum are going to be absorbed, and no light is going to be reflected to your eyes. Therefore, if no light reaches your eyes, then you see no color. It will be dark because no light is coming into your eyes. Therefore, the mind is going to interpret it as black. That's why we see black around us. It is because no light is being reflected to our eyes. Are we together, grade 8? All right, grade 8, remember to ask questions. We've got an amazing team behind the scenes, and the WhatsApp number is 079 578 2908. Our WhatsApp number again, 079 578 2908. Please don't call, don't send voice notes, just type your work. All right, or take a picture, then you ask your questions. All right, let's move on, grade 8. When an object has a specific color, it is because it reflects only that color of light and absorbs all the other colors of the visible spectrum. What do we mean by that? Right? Let's say the surface is red, and then the incident rays are the colors of the rainbow, the visible spectrum. Okay? And then color red, the red light is going to be reflected to our eyes. Then our eyes is going to see color red. Are we together? If it is yellow, we'll see yellow. If the reflected ray is blue, we'll see blue. And what happens to the other colors of the visible spectrum? They will be absorbed. All right. Absorbed colors of the visible spectrum are the ones that we don't see. Then those colors are absorbed. All right. And then let's look at our beautiful coach here. It is cream. And then we see the background here is red. Why are we seeing these different colors? It is because we are seeing the light is getting into our eyes, and our minds are interpreting that light as red because of the red surface, and the couch is cream because of the surface. All right, let's move on. Grade 8. Remember, when you're in grade 7, you learned about radiation of heat and discovered that dark surfaces heat up quickly because they can absorb heat. They heat up quickly. Why? It is because they absorb heat. All right. And remember the effect of color on the absorption of heat. White or pale colors are cooler than dark colors. All right. For example, if you put on something white in summer, you will feel cool. Why? Because it will reflect the heat. But if you put on something black during winter, you'll feel warm and enjoy yourself. But if you put something black during summer, you'll be sweating because it will absorb all the heat. All right? Then it will be very hot. All right. And then that is because light carries energy. Light carries what, grade 8? Light carries energy, which causes heating. So when more light is absorbed, then there is considerable heating effect. That's why when you're putting on a black sweater, you feel warm. And when you are putting on a light color or a white shirt, you feel cool. Okay. The colors play a vital role. All right. For example, here we've got white light that is coming in, then the surface is black. This is our black surface. And then if the surface is black, there is no light that is going to be reflected. All right. Therefore, if our eyes don't receive the light, then the mind will interpret it as black. That's why when you look around in the classroom, you can see color black. Okay, because no light is being reflected to our eyes, all the light is being absorbed. Okay, let's move on. Grade 8. We are going to write an activity now. Let's check the questions together, then I'll give you time to answer the questions. State the property of light that explains each of the following observations. A, you can see yourself on a very smooth, polished surface. B, most of the ink on paper appears to be black. B, most of the ink on paper appears to be black. Then question number 2. Name a difference and one similarity between light that is reflected from a white page and light that is reflected by a mirror. I'll give you 3 minutes to answer the questions. Done grade 8? Good. Make sure you take a picture and send us on 079 578 2908. I want to see what you have written. All right, let's look at the work together. Question number 1 says, state the property of light that explains each of the following observations. A, you can see yourself on a very smooth, polished surface. That is reflection. All right. On smooth surfaces, light is reflected in the same direction. All right, let's look at B. Most of the ink on paper appears to be black. This is absorption. All right. And then red ink looks red because it reflects a what? A red light and absorbs all the other colors. When you mix green, red, blue, yellow, when you mix all these inks, then each ink that you add absorbs more light. That leaves less light to reflect to your eye. Okay, then the colors will be absorbed. And then since the mixture absorbs light of many colors and reflects very little, you may end up with black. All right. And then name one difference and one similarity between light that is reflected from a white page and light that is reflected by a mirror. The difference is that the direction of the light is emitted in, for example, the mirrors. It bounces light in a predictable direction, while white objects scatter light. White objects will scatter light, but the mirrors will bounce back or they will reflect back in a predictable direction. Both the mirror and on the paper, it reflects all light rays. Okay. Who got everything correct? Good, some of you did. All right, let's move on with our lesson. Light is reflected off most surfaces, which is why we can see the objects around us. We can see different objects around us. You can see your stationery. You can see the smart boards. You can see the windows. You can see different things around you. It is because light is reflected off most surfaces. That's why you can see different objects around us. When you look at a smooth surface, it is possible to see what? To see your image on that surface, all right? Because it is a what? A smooth surface. Shiny surfaces make particularly good reflectors. Mirrors reflect light so well that you can see yourself clearly in them, right? For example, we've got a mirror here. It reflects light in a very good way because you can see different items that are being reflected. You can see green pot plants, you can see couches, you can see different items in the house, all right? That's why we are saying they are very good. All right. When light strikes a shiny surface at exactly 90-degree angle, the light rays will reflect straight back. All right. However, when the light rays strike the object at an angle, the light rays are reflected at an angle. All right. Let's make a small diagram here. We are now talking about the incident ray that is coming in. Then we've got our normal, this is an imaginary line. Then we talk about the reflected ray, that is the outgoing ray. All right. And then what about this 90-degree angle? This 90-degree angle we are measuring from the incident ray to the normal, then to the reflected ray. This must be 90 degrees. This is a 90-degree angle. All right. And then we are seeing the mirror there that make you see your reflection clearly on it because it has got a smooth surface. It bounces back the light, right, in a predictable direction. If light strikes a shiny surface at exactly 90 degrees, angle, the light rays will be reflected straight back. If light rays strike the object at an angle, the light rays are reflected at an angle as well. All right. And then reflection involves two rays, that is the incident ray and the reflected ray. And then when I'm talking about the incident ray, this is the ray that is incoming. This is the incident ray. And what about the reflected ray? This is the outgoing ray. All right. When we're talking about incident ray, we're talking about the rays that are coming in to a surface. And then reflected ray, this is the ray that will be reflected from a surface to your eyes. That's why we see color. All right. And then the incident ray is the ray that falls on the reflective surface. The reflected ray is the ray that is reflected from the reflective surface. We've got a very wonderful diagram there. This is our mirror. This is the surface. And then the incident ray is the incoming ray, this one. And then we've got our normal. This is the imaginary line. This is the normal. This is the imaginary line. Then we've got a reflected ray. All right. And then check the angle from the incident ray to the normal to the reflected ray. It has to be 90 degrees. All right. This is 90 degrees. Okay. And then we will see color because of the reflected ray. Because the reflected ray is the one that is coming into our eyes. That's why we see color. Do you get it? Good. Let's move on. Incident ray. This is the light ray that travels to the reflective surface. It is coming to the reflective surface. All right. And then you can think of the incoming ray. This is the incident ray. It is the incoming ray. All right. But when it strikes the surface, then a reflected ray will go straight to our eyes. And then we've got the normal. The normal is an imaginary line on a reflective surface that forms an angle of 90 degrees to the surface. Then what about the reflected ray? This is the light ray that is reflected by the surface. Think of it as an outgoing ray because it will be going to your eyes. And then we've got the law of reflection that states that the angle of incident ray should be equal to the angle of the reflected ray. All right. When we are talking about angle of incident ray and the angle of the reflected ray, this is the angle that we are talking about, incident ray. When you're looking at this angle up to the normal and from the normal up to the reflected ray, this is what we are talking about. This is the angle of the incident ray and the reflected ray. And they form 90 degrees. They form 90 degrees. Okay. Good. Let's move on. Angle of incidence. This is the angle that is measured from the normal to the incident ray. And then what about the angle of reflection? This is the angle that is measured from the normal to the reflected ray. Then we are talking about the angle of incidence and angle of reflection. All right, this is what we're talking about. This is the incident ray. This one is the incident ray. It is the incoming ray. It is coming to the surface. All right. For example, white light will strike a surface and then the reflected ray will come out. All right. It will come to our eyes. While our eyes see light, as soon as it sees light, then we know the color. Okay. Why am I saying that? It is because the other colors of the visible spectrum are going to be absorbed. But the reflected one, it will come to our eyes. Then our minds are going to interpret it as blue if the surface is blue. All right. If the reflected ray is blue. Are we together there? Good. Let's move on. The law of reflection says that for reflection to occur, the angle of incident ray should be equal to the angle of reflected ray. We are talking about these angles now. All right, they should be equal. Okay. And then the reflection of light from smooth and rough surfaces. A mirror has a very smooth surface. On a smooth surface, all the light is reflected in the same direction. For example, let's look at the incident rays here. These are incoming rays to the surface. Then the reflected ray, they will be reflected in the same direction. And then here, on a very rough surface, what's going to happen? The incident rays coming in, but light will be scattered. All right? It will not have uniformity. It will be scattered, all right? Because the surface is very rough. Are we together? Good. And then on a rough surface, different light rays will shine on different parts of the surface. So some might shine on relatively flat parts, and some might shine on parts that are at a greater angle away from the flat surface. The shadow takes its shape from the shape of the opaque object and will form on the side facing away from the light source. What do we mean here? For example, if you take an opaque object, for example, my hand is opaque, and then this is the source of light. When light shines on an opaque object, what's going to happen? The opaque object doesn't allow light to pass through. Therefore, it's going to block the light. When it blocks the light, it will form a shadow on the other side. All right? Especially if the hand is near the light source, the shadow is going to be big and dark. But if we move the hand further away from the light source, what's going to happen? The shadow is going to appear small. Do you get it? Why? Because opaque objects don't allow light to pass through. But if it is a transparent object, it will allow light to pass through. That's why now in our classroom, we can see trees outside. We can see birds flying outside. It is because light can pass through the windows. Okay, it will pass through the windows. That's why we're seeing what is happening outside through the windows, because they are transparent. Are we together, grade 8? Good. The shadow takes its shape from the shape of the opaque object and will form on the side facing away from the light source. Now we know that if we've got an opaque object and then light is striking there, the opaque object will not allow light to pass through, it will block it. Then on the other side, we'll see a shadow. Okay, let's move on. When light is reflected from a rough surface, not all the light is reflected, reaches the eye, and therefore the brain is not able to form an image. Right? The brain will form an image when light enters the eyes, but if it doesn't, it's going to be difficult for it to form an image. Okay, the light is scattered, which means that it reflects in several different directions and with no regular pattern. That is reflection. The smoother the surface, the more light is reflected in the same direction, and therefore the clearer the image that forms. All right, this one is a clear surface, very smooth surface. Then this is very rough. The light is going to be scattered. But on a smooth surface, light is going to be reflected, and then the light will reach our eyes, and then our minds are going to interpret it in different colors. All right, we've got an activity, grade 8. I want you to check the activity, write it down on your own. Let's do it together. First, what is meant by reflection of light? 2, outline the law of reflection. 3, describe how the incident ray and the reflected ray are measured. I'll give you 3 minutes to answer the questions. We hope you are done answering the questions. Make sure you take a picture and send us on 079 578 2908 so that we'll see how you answer the questions. What is meant by reflection of light? What is meant by reflection of light? When light rays approach smooth polished surfaces and the light ray bounces back, it is known as the reflection of light. All right. And then outline the law of reflection. The law of reflection states that for reflection to occur, the angle of incident ray should be equal to the angle of reflected ray. Are we understanding this one? All right. I will draw it again here. This is the surface. Then this is an incoming ray. We call it an incident ray. Let me write it here. Incident ray. Okay, this is incoming. And then we've got our normal. That is the imaginary line. This is the normal. And then the reflective ray. It is the outgoing one. This is the reflected ray. Okay. And then we are now talking about the angle of incident and the angle of the reflected ray. Okay. From the incident ray to the normal, then from the normal to the reflective. This is the angle that we're saying it should be 90 degrees. Do you get it? Because the angle of the incident and the angle of reflected it should be 90. These should be equal. And then altogether it is 90 degrees. Describe how the incident ray and reflected ray are measured. Angle of incidence, this is the angle that is measured from the normal to the incident ray. All right, this is the normal. Remember, normal. And then from normal to incident, it should be equal from normal to reflective. Okay, this is the reflected ray and incident ray. These should be equal, and altogether they should form 90 degrees. Angle of reflection, the angle that is measured from the normal to the reflected ray. Good, let's go to our summary. Light can be absorbed by the surfaces of some materials. All right. And then light is absorbed differently by different materials. A material has a certain color because it absorbs some of the colors and reflects the other colors. We only see the color that is being reflected. If all the colors of the visible spectrum are absorbed, we can't see the color. We'll only see black. All right. And then the frequencies that are absorbed by objects do not reach the eye because they will be absorbed. Therefore, none will be reflected, so we won't see them. And then light reflects off most surfaces. It reflects off most surfaces. Let's look at the incoming rays. This is the colors of the rainbow, the visible spectrum. Okay, light is coming in to a leaf, and then the green light is reflected to our eyes. Therefore, our minds are going to interpret the leaf as green because only the green light is being reflected to our eyes. Right. Remember, we only see color when light reaches our eyes, but if light doesn't reach our eyes, we cannot see any color. It will be black. Light changes its direction when it is reflected. The laws of reflection tell us how light is being reflected. On smooth surfaces, light is reflected in the same direction. Right. And then we've got a good diagram there. We've got the incoming ray, that is the incident ray, and the outgoing ray, that is the reflected ray, which reaches our eyes, and then it makes it possible for us to see the color of different objects, to see different objects in our classroom. All right. On rough surfaces, reflected light is scattered. Objects around us reflect or radiate light with different frequencies that enter the eye. We've got good diagrams there. We've got the incident ray, this is the incoming ray, and then the reflected ray. Why is it in such a good diagram, in good direction? It is because of the smooth surface. And what about a rough surface? Light will be scattered. All right, it will be scattered. Let's check our WhatsApp questions. I'll just give you 1 minute to answer the WhatsApp. Then it seems there are no questions. Grade 8. Hope you understood the lesson. All right. And then let's check our homework. We're going to copy our homework shortly. Let's read it together. State the property of light that explains each of the following observations. You can see yourself on a very smooth polished surface. B. Fish in an aquarium behind very thick glass appear bigger than they are. C. Most of the ink on paper appears to be black. 2. Name one difference and one similarity between light and that is being reflected from a white page and light that is reflected from a mirror. Just take a photo of the homework, then you're going to do it at home, and then you bring your book tomorrow to class. Okay, just take a picture quickly. I hope you've taken a picture. Let's move on. Grade 8. Thank you very much. Hope you enjoyed the lesson. So long for now.